Nihonium, element 113. That has the mass number of 284. So it's 50 nucleons heavier than uranium-234. And we see that it has different shape to it here than iron does. There's iron on the right and the nihonium on the left. And we see that it has a 6-layer pyramid on one end. And then it has a cube underneath that, where a contraction of the big pyramid comes down to 4 layers, meeting the 3x3 cube. It's visible there in the center. And then, as the symbol shows, the silhouette right here behind it, the silhouette here behind it shows the structure that you're seeing in the 3D model. So there's nihonium right here. And it's got the cube at the center with small pyramids on the 4 sides. On the bottom face of the cube, there's this bunch of ledges, and this makes it radioactive. This is why fission occurs. And when fragments come apart from this type of element, there's these 27 nucleons in the cube that can either go in one fragment or the other. That's why you get a bimodal distribution of, say, uranium. Now, uranium is quite similar to nihonium. We see it here. There's uranium. It just has fewer ledges on the bottom. Everything else is the same. So now let's take a look a little closer at this 3D model that is 5 trillion times larger than the real nucleus. Now I'm going to just paint the protons white and leave the neutrons gray. And it's similar to iron. The protons tend to line up in lines of protons. And then it forms a loop around the nucleus, like in iron, but it's not a coaxial loop. So we see that this then would continue around and start twisting into a loop. Goes around the side, and it continues twisting around until it gets to all these ledges over here. And it gets to the bottom of the pyramid. And so that's the proton distribution for nihonium, element 113.